So, questions from last time. Questions from weekly content. And questions from Alex. Yes, Emma, what is your question? No, there was not. No homework from the last class. The first due date for you all is Tuesday the 30th. And I may have misspoke in our first class meeting. I typically have due dates on Mondays, but since I see you on Tuesdays and Thursdays, the due date in here is Tuesday. So that way we will have class the same day that assignments are due. So that way if you have any last minute questions, we'll open up class for some question time. The chart. The chart from your weekly assignments. Yes, you do have your Excel plan schedule, but nothing was due this week. Nothing was due. Nothing is due this week. So you do have that plan schedule from Excel. Download the Excel template, replace out all the letters, make up your own calendar, make your ideal schedule, and then you're going to submit that. Yes. All right, and again, the due date here is Monday the 29th. I don't think anybody's going to need extra time on that. Just make sure to follow the directions on the way you title the file. Okay. Yes, there is. Yes, there is. And I'm not going to tell you the total thing. Let's see, notes, but that's test-wise. For a test, you will have, you use one piece of paper, 8.5 by 11, double. You can write whatever you want to on it in your handwriting. Can't be printed very, very small. It's got to be in your regular handwriting. So you'll have access to that, but not to your full notes. Grades are typically updated. Well, when you do something in Alex, the grades are immediate. Blackboard usually updates once every 24 hours. So if you do something on a Monday, you probably see the change in Blackboard on Tuesday. You'll see the change in Alex immediately. Tests, I try to get anything that we do where you got to submit it and I turn it back within 5 days of the due date, but I really am trying to get that to 1 or 2. So for instance, this lab is due on Monday the 29th. I fully intend to have that back to you by our meeting on Thursday. Hopefully have it back by Tuesday, but definitely by Thursday. And then the tests are online, so reviewing those give me 5 days for that as well. All right. So, Andrew, I'm going to give you one insight here. If you want to have Excel do the work for you, what you can do is go into that hours and use the function count if. And what count if does is you feed it a range, you feed it a set of cells, and then you tell it what are we looking for. So all the cells that I'm looking at are my Sunday through Saturday full week. And then what do I want it to look like? Well, I want it to be, this one was S. So I'm going to use this, the string S, and then it'll count them. The other thing you can do here is if you have a cell that looks like what you're looking for, you can also just feed it the cell name instead of putting the actual string in. And we have that. That happens to be sitting right here. So that is cell J5. So if I instead of putting in a string, I tell it, I'm calling it, I'm telling it, go look in this cell and show me, give me the number of cells that match. Then there it is. Okay, so I'll let you take it from, y'all take it from there. And again, we're recording, so you'll be able to come back and play this, but keep playing with that. I will tell you that if you grab and pull down, it's not going to work. And the reason is when you grab and pull down, the range automatically grabs and pulls down. So you can grab and pull down to copy, but then you've got to change the range and make it go back so that it's counting all of them. So notice it's missing the first hour. Now, if I do that grab, or if I do the double click, if I come down here and double click, same thing, it's going to do that. So you can stop that with dollar signs, but I'm going to let you play with that because learning Excel, one of the big things of learning Excel is messing around and playing with it. All right. And of course, if you got questions, specific questions, you can always send them to me. All right. So lecture is behind. I did not need to tell you that, you know it. Okay. What percent? So it's going to be the number of hours that each letter takes up divided by the total number of hours in the week. And then that'll be a decimal, convert that to percent, and round it to 1 decimal place. Okay, it's very similar to coding. Yeah, that's the process. All right, so now we are behind. So what I'm going to do is I've got the lecture, I've got all my notes posted, or at least copied over through the end of this chapter, the review chapter. So the skill questions and anything that is practice on here for y'all, I'm going to leave blank and leave it for y'all to do. What I'll do on my end is I will create some videos of me doing the skill practice problems and then post those. So that way we can still get through the material. We're going to be behind for just a little while, but I'm not worried about it. It's fine. But I just want to make sure we have time to get through everything. So the last thing we did was the factor by grouping with 4 terms. We saw where you can break up, you can group the first 2 and last 2 terms, and that works. Or you may have a problem where you can't group the first 2 and the last 2. You may have to swap order. You want to group them so that each grouping has something in common. All right. So last thing is factoring trinomials, and you have done this. I talked to my mother-in-law. Someone mentioned MAT-4. If this carries over, I think MAT-4 was advanced math, modeling and functions, but I could be wrong. But that's what we used to call advanced math. It's the class before calculus. So if you've been in MAT-4, or probably even in MAT-3, you have seen this already. So factoring trinomials. All right, so let's get started over here with easy case. I have a trinomial, x squared minus 8x plus 12. It's trinomial because it's got 3 terms in it. And what do I need to do? Well, if this is going to factor, it is going to factor into 2 binomials. There's no first step in factoring. Make sure if there is any common factor in all the terms, pull it out. There isn't one in this case. So what do I need? Well, I know this is going to factor into x, and then I'm going to have pluses and pluses, not sure yet. And then I'm going to have some number here and some number here. So let's figure out what we have. First, let's figure out the signs. Okay, so I am multiplying to get 12. Twelve is a positive number, so that means I'm either multiplying 2 positive numbers or 2 negative numbers. And then they need to add to -8, the coefficient of b. Well, if I'm multiplying to a positive 12 and adding to -8, that tells me my signs must be what? Plus plus, plus minus, or minus minus. Multiplying to a positive, adding to a negative. everybody follow that idea? If I multiply to a positive and add to a negative, I know that I can only do this if I have two pluses or two positives or two negatives. If I've got two negatives and I add them together, I get a negative. If I have two positives and add them together, I get a positive. So this must be minus minus. Now, back to the left. So to get these last factors, or to get these last terms, I need two numbers that multiply to 12 and add to negative 8. What are they? Well, how many ways are there to multiply to 12? 12 can be written as 1 times 12. I know they have to be negative. If I add those, do I get negative 8? Nope, I get negative 13. What about negative 2 and negative 6? Add those together, get negative 8. There it is. So x minus 2, x minus 6. And that's all there is to it. All right. So we do have some, there is, in this case, I do have a bit of material where I expect you to have some background knowledge, right? So when I'm writing these out, this should be review. If it's not, there's plenty of practice out there, but that procedure should seem or sound familiar. So let's come over here to the next problem. I got 10x cubed plus 105x squared y minus 55xy squared. All right, so first step, are there any common factors? Yes, there are. All right, so 10, 105, and 55 are all numbers, obviously. They're all numbers. If just the first two have, well, no, all three of them end in 0 or 5, so there's a 5 in there, right? So that means I can factor out a 5. How about the variables? Are there any variables that exist in all three terms? X cubed, x squared y, and xy squared. Y doesn't appear in all of them, but x does. All right. And when I factor out that 5x, remember what I'm doing is I'm saying each one of these terms has a factor of 5x in it. So what's left is I'm going to take my term, divide it by what I pulled out. 10x cubed divided by 5x. 10 divided by 5 is 2. X cubed divided by x is x squared. Plus 105 divided by 5 is, we'll move my notes as well. 105 divided by 5 is 21. X squared y divided by x is xy. And negative 55 xy squared divided by 5x. Negative 55 divided by 5 is negative 11. Xy squared divided by x just leaves me y squared. All right. And now if you have done this stuff before, if you've done factoring before, this one may be this one's definitely a little more difficult than my problem over here to the left is, because notice in that first problem, I have a leading coefficient of 1. Here I don't. My leading coefficient is a 2, so this is going to take a little bit more work. All right. So let's use the same idea that we did before. Now, my leading coefficient is a 2. That is a prime number, and that's always a good thing. My leading coefficient is prime. There's only one way to multiply to get it, and that is 2x and x, right? And again, we're ignoring fractions because yes, you could do 4 1/2, but we're just dealing with integers as coefficients. So is everybody cool? X times x is 2x squared, and there's no other way to do that. Now, hands up if that's good. All right. That's what I like to hear. Okay. Good, good, good. So how about the last two? Well, in my last term, it's negative 11. Okay, so I need to multiply two things to get negative 11. So I have to have what kind of signs? Well, they have to be alternating. right? If I'm going to multiply two things to get a negative, one has to be positive, one has to be negative, right? So, well, 11's prime. Well, that's great, because the only way to get 11 is 1 and 11. So what do I have? Well, I've got, in some way, 1 and 11. Now, here's the part that's probably a little off, is the last term has a variable in it. We're typically used to the type of factoring we see over here to the left, where the trinomial only has a single variable. Well, this one has two, and that's fine. Because how do I get y squared? Y times y. So I know that this is 11y and y, and I've just got to figure out which arrangement do I have. Did that get it? So what are all the possible arrangements? Well, I know I'm multiplying to a negative, so I could either do, I could have plus minus, I could be looking at minus plus, and because my leading coefficient's not 1, I have to respect that I could have the y and the 11y in the wrong place. Plus 11y or plus y minus 11y. So which one of these gives me what I started with? Which one of these products, if I multiply, let's get rid of this for a second. And I'm going to nail it down to these. The second one. So the second one, if I FOIL this out, I get 2x squared. Where's my pen? There it is. 2x squared, first outer, plus 2xy minus 11xy minus 11y squared. Right? 2xy minus 11xy is going to give me negative 9xy. So that one's not going to work because I need to add to 21. So anyone else? Oh, I think I was looking at the third. All right, let's try the third one. So we know this doesn't work, and that's information, right? That's good for us to know. So ignore that one. Let's go to the third one. 2x times x, 2x squared. Outer 2x times 11y is positive 22xy. Inner negative y times x is minus xy, and then negative y times positive 11y is negative 11y squared. Combine the middle two, that's 22xy minus xy. Which is going to give me 21xy minus 11y squared. There it is. That's what we started with, right? So since that's what we started with, I have my factorization. And so what does this look like in the end? It looks like 5x times this one, 2x minus y times x plus 11y. Now, that is one way to handle that. That is not the only way to handle that. Okay, so I'm just flipping through the chat here. Another way to handle that is called the bottoms up method, whenever that leading coefficient is not 1. So I'm going to come down here and show you the process one time. If you followed what we did there and that makes sense, great. If not, that's okay. Nothing's wrong. We just need to take a little bit of a refresher or just a reminder. So the problem that I had was after I factored, I had 2x squared plus 21xy minus 11y squared. Now, the bottoms up method, which is kind of a mixture of the AC method, what it does is it lets me pretend for a second. So bottoms up says take A and C and multiply them. So A is 2 and C is negative 11. I'm going to take A and C, I'm going to multiply them, and I'm going to write that product as my last coefficient. So notice the 2 goes out from in front here. And now I have x squared. The middle term is not affected. And 2 times negative 11 is negative 22y squared. Now, if this is factorable, if you can break this trinomial up, this resulting trinomial will factor. Does it? Yes, it does. Two numbers that multiply to negative 22 and add to positive 21. Well, they are what? Positive 22. That's a y there. And negative 1y. Okay. Now here's the catch. Remember that we multiplied A and C together. So now I have to undo that step. And what that leads me to is whatever I found to be the two multiplying factors, I now divide them by whatever A was to start with. So there's A, and here it comes back. So some of these will simplify, some of them won't. X plus 22y divided by 2. 22 divided by 2 is 11. Y is still there. Now this one will not simplify because there's no coefficient, or the coefficient is 1, so there's no division to be done here. Whenever that happens, we can rewrite that denominator as the coefficient in front of x. And there is the factored pair. Does that match up with our factoring? Yep. That is that. Okay. Now, that is not a required way. I know that there's something called the cross method or the X method that was being taught before I came through school. If you can factor these in your own way and get the correct answer consistently, use the way that works for you. If you are not good at it yet, give these two a try, right? They would call this process a reverse FOIL. And you can imagine, so in this example, my leading A, the coefficient here of A is prime, and the coefficient for C is, or coefficient for the last term, which is C, is prime. If they're not prime, there are so many different cases that could happen. If this was 22 or this was 4, I couldn't narrow it down to just 2 and 1 every time. It could be 2 and 2 or 4 and 1, and the signs could be different. So reverse FOIL is great if I've got prime numbers, not so great if my A and C are not prime. All right, so like I said, I'm going to leave this skill practice for a video later. Questions there? Any problems following along, at least with the reverse FOIL, with not as much the reverse FOIL as the bottoms up? Is everybody okay with that? Yeah, practice. That is absolutely just like my writing on this tablet. It's requiring a lot of practice. All right, so that is the end of R3. We're going to go ahead into R4 now. R4 deals with rational expressions. Yes, R4 is dealing with rational expressions. So rational expression, okay, what does it mean? Well, right here at the beginning of the word, part of rational, you see ratio, right? So ratio means what? I've just got two numbers that are divided, right? So because of that, what is a rational expression? It's a case where I have a numerator and a denominator, and I have a variable sitting in the denominator for the most part. It doesn't have to be there. all I gotta have is a numerator and denominator. If there's no variable in the denominator, you can rewrite as a fractional. So if I have 2x over 3, that is a rational expression, but I wouldn't deal with it as a rational expression. I would write it as 2x over 3. If I have 2 over 3x, I can't do that. That's not the same. I can't pull that out. I can't pull the 2/3 out front or call that the coefficient because x is sitting in the denominator. So these are really mainly cases where there's a variable in the denominator. The problem tells me to simplify these, which means just divide. Divide if possible. So my first one here, my numerator is 3x cubed y. Denominator divided by 27x to the 4th. So do your division. 3 and 27 both have a factor of 3. You might think you printed the wrong notes. No, this one should match up. Now the writing at the top would be R4. Your notes look like R4 and it looks handwriting is the top, but the problem should still match up. Is that not the case on the printed notes? All right. Oh. All right. Well, let's go with it. And again, like I said, we got the video, but check under the guided notes for R4 and see if at least the problems line up. But let's go ahead and do this division here. 3 and 27 both have a factor of 3. 3 divided by 3 is 1. 3 divided by 27 is 9. All right. I've got x's in common. This is x cubed. This is x to the 4th. Both of these have an x cubed in common. So x cubed divided by x cubed leaves me a 1. X to the 4th divided by x cubed leaves me what? X to the 1st, or just x, right? When I'm dividing the same base with different powers, I subtract the powers, right? So x to the 4th divided by x cubed leaves me x to the 1st. Y is still in the numerator. It's not in the denominator. It's not going to simplify out. So what are my remaining factors? I have 1 times y in the numerator. The denominator, I have 9 times x. I'm showing you way more work than you need to see because the 1s are not going to be part of the final answer because 1 times 1 is 1. 1 times y is y. Denominator 9 times x. It's just 9 times x. And that's it. All right. So next, we've got a little bit of work to do here. 2x squared plus 7x minus 15 divided by 4x squared minus 12x plus 9. Both of these will factor. All right, 2x squared plus 7x minus 15. I'm going to go ahead and do the factoring for you. Because both of these have a coefficient that is not 1. But the numerator factors into x plus 5 times 2x minus 3. If you want to, absolutely check. Multiply these back out and see if you get your numerator. And then the denominator is, well, it turns out this is a perfect square, right? 2x squared minus 12x plus 9 factors into 2x minus 3 times 2x minus 3. And then again, I know I'm going fast. I know I'm scooting past the work here, but that's just because I'm behind in the lecture. 2x minus 3's divide away, and I'm left with what? Got x plus 5 in the numerator and 2x minus 3 in the denominator. when I make the video, I will go back and show you the bottoms up method to show you the factoring for those middle ones. But I think the goal here is not testing your factoring skills so much as it's just making sure that we can simplify rational expressions. The last one. Now, this one, the numerator, you may not see it immediately, but it is the difference of cubes. All right, and the difference of cubes is what? Sorry. Difference of perfect cubes. I cannot write with this. There we go. There I am. All right. So the difference of cubes says if I have two perfect cubes, that this will break down into a minus b times a squared plus 2ab plus b squared. This is just a rule from the textbook. It is not a situation where you just know that off the top of your head. So do I have this? Yes. Yes, I do. I have it right there. M cubed is just m times m times m. 64, that's probably the tougher one. The cube root of 64 is 4, right? So that means m cubed minus 64 is going to break down into m minus 4 times m squared plus 2 times m times 4 plus 4 squared. So everywhere there's an A, I'm putting an m. Everywhere there's a B, I'm putting a 4. That cleans a little bit. M squared plus 8m plus 16. Now, that is my numerator. Okay. How about the denominator? All right, let me just make a note here. Just so we don't lose ourselves. The easiest thing to do in math is when you apply one step, you get to the end and people are like, yep, I'm done. No, that was to simplify the numerator to see if there's any more work to be done. So don't immediately think you're done just because you've reached what's not. This doesn't answer the question that was asked. What's the denominator? The denominator is 16m minus m cubed. Now, is this the difference of perfect cubes? The second term is, but the first term is not. All right, so what can I do instead to factor here? Well, both of these have a factor of m in it. So I'm going to factor out that m. It's going to leave me 16 minus m squared. This is the difference of squares. 16 squared is 4. M squared is m. Or square root of 16 is 4. The square root of m squared is m. So that means this breaks down into 4 minus m times 4 plus m. Backwards, isn't it? We're used to seeing m minus 4. Yeah, that's exactly it, Andrew. You're used to seeing m minus 4 and m plus 4, but my difference of cubes are backward. My difference of squares are backwards. 16 is the first term, m squared is the last term. So I have to follow that pattern. So instead of having m minus 4, I have 4 minus m. Instead of having m plus 4, I have 4 plus m. So this is my simplified denominator. So all that work off to the side, which is why scrap paper is absolutely necessary in math. And what do I have? I have my numerator is m minus 4 times m squared plus 8m plus 16. My denominator is m times 4 minus m times 4 plus m. Are there any common factors? Yes, the order. So it looks like it, right? So let's write that denominator. Let's get those m's in the order that we're seeing them. So m minus 4 times m squared plus 8m plus 16 divided by m times, now that is negative m plus 4 times m plus 4, and 4 plus m are the same thing because addition is commutative. Okay, now these are not exactly the same yet, right? These aren't exactly the same, but they're close. How close are they? Well, they just switched signs, aren't they? M minus 4, negative m plus 4. That m and the 4 just have opposite signs. Well, if they both have opposite signs, what if I factor out a negative from this, from negative m plus 4? Factoring out a negative swaps the signs. So negative m becomes m, positive 4 becomes negative 4, and now they match, right? So I'm going to write that out. I'm going to keep writing the numerator because it is important that this keeps going. So numerator, m minus 4. If you're trying to figure out how do I know I'm not done, how do I know I need to go on? Well, if this is going to reduce anymore, m squared plus 8m plus 16 is not going to factor. So the only way this is going to factor is if that m minus 4 somehow goes away or somehow divides out. So I've got the negative 1 that I factored out times m minus 4 times m plus 4. Good. And now we can divide the m minus 4s away. Those leave 1s. And what am I going to be left with? I'm going to be left with, the numerator is m squared plus 8m plus 16 over, I think you're right, Andrew. I think I have factored this wrong. I think this is 2 times a times b. Yeah. No, 2 times 4 is 8. This is right. This is your 8s. But it doesn't. B is m is 2 times 4 is 8. 2 numbers multiplied is 16. And it does factor. Well, look at that. All right. I'm glad this one's on video because we're going to have to chase down the answer here. All right. Andrew's right. Andrew's mentioned that my trinomial that's left over actually does factor. So in the numerator, I've got, let's get the step we were doing done first. In my notes, I had that as 4m in the middle. That's why I didn't see it. And the denominator is negative m times m plus 4. Now, Andrew said that the numerator is factorable. 2 things multiply to 16 and add to 8. Yeah, that's 4 and 4. So the numerator can be rewritten as m plus 4 times m plus 4. The denominator is still negative m times m plus 4. Same thing as last time, right? I got the same factor in the numerator and the denominator. They divide away. And what's left? What's left is m plus plus 4 divided by negative m, or negative m plus 4 over m. Okay. All right. So, can I go any further than this? No, I can rewrite that is m divided by m plus 4 divided by m, but that is perfectly fine the way it's written. I cannot divide those m's. Okay, I know there's a temptation to do it. I still feel that temptation every time I do a math problem, but I cannot divide these m's out, because in order to divide an m, all the terms of the numerator and all the terms of the denominator must share it. So that's as far as I can go. That is the answer, negative m plus 4 divided by m. And if what I said earlier is I have a single term in the denominator, so I could rewrite this as each piece written, m divided by m is 1. And then this would be, because the minus goes to both. So negative m divided by m is negative 1. 4 over m is 4 over m. That is the finalized answer. I like that one better, though. They're the same thing. All right. So what's next? Let's take a look at the one up here on the at the top left with the practice. To simplify, 8x minus x squared over x squared minus 7x minus 8. Okay, lots of work to do here. First thing always when I'm trying to factor, do I have a common factor? Yeah, the numerator has one, right? There's an x in both of those. So factor out the x. That's going to leave me 8 minus x. That's so much easier than having to factor all the way out, right? That is factoring, but that's much easier than factoring out a trinomial. What about the denominator? X squared minus 7x minus 8 multiplied to negative 8, add to negative 7. Yes, Emma, I did. So Emma asked, did I factor the negative 1 out of just the negative m plus 4? That's exactly right. Mm-hmm. All right. 8 and 1. Yep. 8 and 1. And I'm multiplying to negative 8, adding to negative 7. So that means I know the numbers are 8 and 1, and which sign goes with which. If the middle term is negative, the magnitude of the negative number is larger than the magnitude of the positive number. I know they're opposite sign because they multiplied to a negative. The sign of the middle term tells me that not only did they multiply, when they multiplied, they came out negative, but when I added them, the result was negative. Okay, same thing that we saw in the last one. I have what look like the same thing, they're just off by a sign. Right, I have 8 minus x over, and now that I think out loud, you're used to seeing the x plus 8. So I'm going to factor that negative out up here instead of factoring out of the x minus 8. Now, it's going to feel like that works all the time, and it doesn't. So if when you're doing those problems, if you get one of these cases where you can divide or you can factor out a negative and it swaps the signs, take a second look and make sure that you're right. Because the temptation is to, once you've seen that trick, always there, and that doesn't always happen. So end up with negative x over x plus 1. Why did I do that? All right. Yes, that one was quite a bit easier, I agree. All right, so this is working with rational expressions. Questions. And again, you can send them to the everybody chat, or if you just want to send them to me, you can send them to that LT questions. Okay. All right, so let's go on to the next page. And this is the bottom of the page if you're worried. Next is adding and subtracting rational expressions. All right. So in order to add and subtract, that's going to do that 14 times. What we have to do is, in order to add or subtract anything, we have to have the same denominator, right? So in order to add and subtract rational expressions, I've got to have the same denominator. To have the same denominator means I'm going to find the least common denominator of both or three or all the terms that I'm dealing with. And I'm going to multiply each term by whatever I need to make the denominator I want. So let me, again, when I talk it out loud in math, it doesn't really help. It's because it can just get jumbled and confused. So instead of talking it, let me show you what I mean. So for this problem, I have 7 over 4a plus 11 over 10a squared. Okay, what is the LCD here? LCD is the least common denominator. It is the smallest multiple that both denominators will go into. They're easy to find when you have two numbers. When I throw variables in, people get a little bit afraid. So Andrew has mentioned that it's 2a. 2a is the least common multiple, or excuse me, the greatest common multiple. That's the largest, or the factor that has the most terms that go into the denominators. But what I want is the LCD. So to get the LCD, I'm going to take my denominators, and again, I'm doing more work than I need to see, and break them down into what's called their prime factorization. So if it's 2 times 2, and a is a, so that's one denominator. For the next one, the other denominator is 10a squared. Break down 10 to its prime factors, it's 2 times 5, right? And then a squared is a times a. So these are the prime factorizations of the two denominators that I have. If I want to find the LCD, what I do is any factor that appears in both or all of the denominators I'm looking at is multiplied once. So there's a 2 and there's an a in both of those. So I multiply by 2, I multiply by a, and then every factor that's left, I multiply by that once. So the 2 from up here comes in, the 5 and the a. Multiply that all together, and what do I have? 2 times 2 is 4, 4 times 5 is 20, a times a is a squared. So this is the LCD. All right, so that's the denominator that I want each of these to end up with. So how am I going to do that? Well, remember I told you that, I told you last time that yes, I need to get them to the same denominator. And I told you that one trick in math that's something that you always see is find a clever way to add 0. For this, I need a clever way to multiply by 1, right? So to multiply by 1, I have 4a, I want 20a squared. Well, to get 20a squared, 4's got to be multiplied by 5 to get 20. A's got to be multiplied by a to get a squared. If I do it to the denominator, I have to do it to the numerator, because here's the other main trick we use in math. This is a clever way of multiplying by 1. So plus, and then what's my other term? 11 over 10a squared. 10a squared, LCD is 20a squared. The only thing it needs is to be multiplied by 2. So let's do the math. And 7 times 5a is 35a. 11 times 2 is 22. Now, here's the key feature. Remember, I did all that work so that I would have the same denominator. Both of these fractions have a denominator of 20a squared. So I can write it all over the same denominator, because that was the goal. That was what I was trying to get out of it, is to get the same denominator. Now, if you are looking at that and saying, oh, I can rewrite those, I could rewrite this as 35a over 20a squared plus 22 over 20a squared. You could, but that would just undo all the work we just did. So we don't want to do that, okay? So as we get into R4 here, the tough part again is going to be figuring out when we're done, right? Because this problem says to add and simplify. Well, this is simplified. All right. How about example 5? Okay, example 5 has quite a bit more work, but I think we're going to be okay. So subtract the rational expressions and simplify the result. So I have what going on here? I have, first, I want to see if I have any division that I can do, right? I've got 2 rational expressions here. They're subtracted. 3x plus 5 over x squared plus 4x plus 3 minus x minus 5 over x squared plus 2x minus 3. So I'm going to jot these down up here really quick. I'm just going to grab the denominators for now. X squared plus 4x plus 3. That factors into x plus 3 times x plus 1. My other denominator is x squared plus 2x minus 3. That factors into x plus 3 times x minus 1. All right, so this was the denominator of the first. This is the denominator of the second. And what did I do last time to get the LCD? If there were any factors that were shared, I multiplied by them once. Any shared factors here? Yeah. X minus 3 appears in both. So I'm only going to write that once. I said minus, but I meant plus. I'm sorry. X plus 3 appears in both of my prime factorizations. Now everything else only appears once, so that means I've got the x plus 3 times x plus 1 times x minus 1. That's my LCD. It doesn't look like an LCD because it's hard to remember that x plus 3, quantity x plus 3 is a single number. Doesn't look like it, but it is. Because if I give you x, before you can do any math here, you're going to add 3 to it. So that is a number. It's just, what is a number? Well, it's whatever x is. When you give me x, add 3 more. So this means I've factored my denominators. So I can rewrite my denominators. So the first term here is 3x plus 5. I'm dividing by x squared plus 4x plus 3. Well, we just did the work and said that this is x plus 3 times x plus 1. I want x plus 3 times x plus 1 times x minus 1. How do I do that? Well, I multiply by it. If I multiply the denominator by x minus 1, I'll have my LCD. I'm allowed to do that as long as I do the same thing to the numerator, right? And that's a critical step. You've got to do the same thing to the numerator. Minus, what have I got over here? I've got x minus 5 divided by, what is my denominator? X squared plus 2x minus 3. Well, that was factored into x plus 3 times x minus 1. What is it missing? It is missing the factor x plus 1. So I'm going to multiply by that. And what do I have now? Well, three x plus 5 times x minus 1 minus x minus 5 times x plus 1, all divided by x plus 3 times x plus 1 times x minus 1. Multiply, so I've got following the order of operations. The numerator has some multiplication to do. I'm not going to multiply out the denominator because I want to leave this in factored form if I can. The numerator, remember the whole goal here was to do subtraction. The whole goal of this problem was to actually be able to subtract those two pieces, right? Subtract my two rational expressions. So I still need to do the work up here. I need to multiply the numerators. So I'm going to do that. 3 plus 5 times x minus 1. That is 3x times x is 3x squared. 3x times negative 1 is negative 3x. Inner is 5 times x, which is 5x. And 5 times negative 1, negative 5. Minus x minus 5 times x plus 1 is x squared minus 5x plus x minus 5. And again, this is all divided by x plus 3 times x plus 1 times x minus 1. Okay, now you can handle the next step, or let's combine like terms first, and then I'll tell you the next step. Anytime you do that trinomial, always look to see if your middle terms are like. If they are, go ahead and combine them. Negative 3x plus 5x, negative 3 plus 5 is 2x. And in the middle here, I have negative 5x plus x, which is negative 4x, and minus 5, all divided by x plus 3 times x plus 1 times x minus 1. Now, next step. Notice I keep writing that last, that second trinomial in parentheses. That's because this subtraction applies to the result of x minus 5 times x plus 1. So that means this needs to be distributed to each term. So what do I have now? I now have 3x squared plus 2x minus 5 minus x squared minus negative 4x, which is plus 4x, minus negative 5, which is plus 5, all divided by x plus 3 times x plus 1 times x minus 1. Let me say it again. We're going into more detail than I need to see, because if you can stop here and say 3x squared minus x squared and do the process that way, that's absolutely fine. But let's combine like terms now. 3x squared minus x squared leaves me 2x squared. 2x plus 4x is 6x. Negative 5 plus 5 is 0. So my constant term goes away. My denominator is still the same. X plus 3 times x plus 1 times x minus 1. Is there any more to do here? Look at that numerator. It's a binomial, but it has some common factors. So let's get those out, right? We need to be in factored form. 2x squared and 6x both have a factor of 2x. And what is that going to leave me? 2x squared divided by 2x is x. 6x divided by 2x is 3. Hey, wait a second. It's like I knew this was going to happen. And look at that. So why didn't I multiply out the denominator? One, I didn't want to. And two, if I'm trying to write this in factored form and simplified, I would have never seen that division right there if I had multiplied this out. So divide those, that leaves me a factor of 1. So what do I have? I have 2x over x plus 1 times x minus 1. And I cannot do any more, right? There's nothing left in the numerator to be common with the denominator. I don't even have a binomial in the numerator at this point. Okay? So you've got the 2 skill practice problems there. Again, I'm going to come back and deal with this and work some videos into the problem so that you see everything. But how are we feeling about this? These seem long, don't they? Whenever I have these, whenever I'm adding and subtracting rational expressions, the problems can get long. And that is, yeah, these do feel better. That's good. Okay. So yes, they can get long. Yes, start collecting scrap paper so that you can do your work on there. This thing has been so annoying. I'm sorry. Good time to mute my phone 5 or 10 minutes before the end of class. But let's go on and let's deal with the next section of R4. All right. Yes, Gabrielle, there are practice problems like this in Alex. So yeah, and then this is an R4. Last bit's in R3. You'll be seeing all of this throughout the homework, and you've got plenty of attempts to tackle it. All right. Good. Can you use a drawing pad? Sure. Sure, you can use a drawing pad for this. Yeah. Yeah, I agree. All right, so let's deal with complex fractions now. Now here is, it's odd that that mathematicians weren't more careful here. Complex fraction seems to indicate complex numbers, but it's not. Okay, and I think that I imagine there are a lot of people that feel the way you're feeling, that you know it, but you're not actually learning it right now. Yeah, that you're dealing with, that you're trying to write furiously to keep up, and it's just not, it doesn't have time to sink in. And that's it. This is me showing you how to do it once, and then it's during that practice, during those multiple attempts and trying again, that's when it really sinks in. So I'm just showing you the process once or twice, and then you doing the process over and over is getting it. Yeah. Yes, so what I was saying, complex fractions. Complex seems to indicate that complex numbers are involved, but they're not. Complex fractions are also called compound fractions. All right, and what they mean is I have a fraction in the numerator, the denominator, or both. These are also called, like I said, compound fractions. AKA. So what does it mean? Like I said, it means I have, get the pen off of the way here. And this means we have a fraction in numerator or denominator of a rational expression. All right. So how do I deal with these? There are 2 ways to deal with compound fractions. The first one is to do the math that is set in front of you following order of operations. So for the first one, or for my problem here, I have x minus 4 divided by 4 minus x. Excuse me, said that all wrong. X divided by 4 minus 4 divided by x, all divided by 1/4 plus 1 over x. So in the way it's written right now, I have two problems. I need to deal with the numerator. I need to deal with the denominator. So to do that, I need the LCD of the numerator. What is it? Well, the two factors that make up the numerator are 4 and x. So common denominator I want to get for this subtraction to occur is 4x. How about for the denominator? Well, it's 4 and x again, right? So I need to make the numerator into a fraction that has a denominator of 4x, and I need to do the same thing with the denominator. Yes. So what do I need to do? That means I'm looking at x minus 4 times, I have 4, I want 4x, so I'm going to multiply by x over x minus 4 over x. I have a denominator of x, I would like a denominator of 4x, so I need to multiply that by 4 over 4. Now, this is the numerator of the original. So there's the, oh, straight lines. Straight lines are my enemy today. Divided by, the denominator is 1/4. I want it to have a denominator of 4x. And lastly, 1 over x, I wanted to have a denominator of, I made that mistake. Let me talk it all the way out. So denominator in the common LCD of the numerator is 4x, the LCD of the denominator is 4x. I have 4, I want 4x, so I multiply the first by x over x. Over here I have x, I want 4x, so I multiply by 4 over 4. What does this do? Okay. This does what x times x is, it's x squared over 4x minus, oh, and let's go ahead and do this all in one step. I've got the same denominators. Both of these multiplications are going to result in denominators of 4x. So that means x times x is x squared. 4 times 4 is 16. So there's the numerator. The denominator, 1 times x is x. 1 times 4 is 4. The operation between the fractions was minus in both, so that's why this minus makes its appearance here. So I've got x squared minus 16 over 4x, all divided by x minus 4, 4x. This is division with fractions, okay? No one has ever taught you to divide by fractions. What we've always done is say division is the same thing as multiplication by the reciprocal. Multiplying by the reciprocal is so much easier than dividing by fractions. So what do? Numerator is 4x, x squared divides 16, all divided by 4x. Denominator is x minus 4 over 4x. So copy, change division to multiplication, and then flip. And there is work to be done now, right? So this becomes x squared minus 16 divided by 4x times 4x divided by x minus 4. Is there any simplification I can do here? X squared minus 16 is the difference of perfect squares. So I can rewrite that as x plus 4 times x minus 4. If you were playing along at home, you probably saw that I have a 4x in the numerator here and a 4x in the denominator here. Those will divide away. Absolutely. By factoring that x squared minus 16, I can now see that I have a x minus 4 in the numerator and denominator as well. So I'm going to divide those away. And what's left? Well, the numerator is x plus 4 times 1, which is just x plus 4. The denominator is 1 times 1, which is 1. So would you believe that entire problem breaks down into x plus 4? Crazy, right? Questions? Issues? All right. So it is 2:13. Starting another problem is probably not the best idea, but I'm going to do it anyway. I'm going to start this one because I just want to make sure those negative exponents don't confuse anyone. So what I have here is d to the negative 2 minus c to the negative 2 divided by d to the negative 1 minus c to the negative 1. Now, if you remember, negative exponents mean wherever I am, that is not the right place. If I'm in the numerator, I'm actually supposed to be in the denominator. If I'm in the denominator, I'm actually supposed to be in the numerator. Now, this problem adds an extra wrinkle of difficulty because these are separated by subtraction. So I can't just take this d squared, or d to the negative 2, and put it in the denominator. I need to write d to the negative 2 as 1 over d squared. Moving it to the correct place is what makes the power change signs. So d to the negative 2 is 1 over d squared. C to the negative 2 is 1 over c squared. D to the negative 1 is 1 over d. And c to the negative 1 is 1 over c. Now this looks like the problem we did above, right? That one looks that looks like something you've done before. So I'm going to leave this one for you to finish, and this next piece. All right. In this case, my denominator doesn't have a fraction in it, just the numerator does, and it's just one fraction. So to do this problem again, I'm going to find a common denominator. What is the common denominator, the least common denominator here? Well, the denominator of the first term is 1 plus h. What's the denominator of the second term? The second term is just a 2. Anytime you see a number written by itself, we can always write that as that number over 1, right? Because anything divided by 1 just gives you back what you started with. So my LCD is 1 plus h times 1, which is just 1 plus h. So I need to multiply the numerator and denominator of 2 by 1 plus h, combine like terms, and then divide by h. But this will be left for you to do as well. All right, so like I said, I know we're getting behind. I can feel it too. The video, the fact that this is being recorded, I think is going to help. And then once I get my videos, or once I start turning those out and getting some stuff posted to you, that's going to help as well. So any questions out there in internet land before we call it a day today? Any issues getting into Alex? I'll go ahead and stop the recording because that's the end.